Uh, we're starting chapter 6, and we're going to start moving away from triangles and more talking about, and quadrilaterals, and start talking about polygons. So, in general, a lot of it will be on quadrilaterals, but a polygon, the definition is a plane figure that meets these two conditions. So it needs to be formed by 3 or more segments. So if it's formed by 3 segments, it would be a triangle, but it could be more. Um, and such that no two sides with a common endpoint are collinear. Um, so they're basically saying um, no two sides with a common endpoint. You can't have a side start here and here. That's not a side. Um, can't have a straight line like that. Each side has to intersect exactly two other sides, one at each endpoint. So here's a side, it has to have one side coming out of that endpoint and one side coming out of that endpoint. And then, of course, these endpoints would also have to have them as well. Okay, and that one kind of, you wouldn't want it to be down there at all. You'd want to make sure that those parts connect up nice. So that would be an example of a polygon. So looking at these, this is a triangle. Okay, so it's a polygon. This figure, if you look at this intersection point, this endpoint has actually 4 sides coming out of it. So it is not a polygon. It's got to stay over here. This side, this endpoint has 2 sides coming out of it, but this endpoint only has 1. So one thing I talk about sometimes is that a polygon has to enclose an area. It has to be closed up. You can't let it be open. Here's another example of a figure that at this endpoint has 3 different sides coming out of it, or these 2 sides here are collinear, so that's not a polygon. This thing shaped kind of like a backward C is a polygon. Okay, it encloses an area. Each side has at each endpoint there's a side. Here's another example of a polygon, and this figure I kind of sketched myself is not a polygon because of the curved edge. It's got a curved edge. It's not a polygon. Okay, they have to be line segments. Classifying polygons by the number of sides. So a lot of these you should already know, like a triangle, quadrilateral, pentagon, hexagon. Now, heptagon is probably new for most. You might want to study that one. Octagon, like a stop sign. A nonagon, a decagon, dodecagon. If you remember, like in the metric units, there's a decameter, means um, 10 meters. So deca means 10, and hence 10 sides. A dodecagon is 12 sides. And in general, we can talk about an entagon having n sides. So, or some entagon, it has a variable number of sides. Concave and convex is another way of describing polygons by their shape. And this polygon is convex, this one is concave. If you read the definitions, if you drew a line through any side, if it goes through the polygon at all, it makes the polygon concave. And I just remember concave, it has to go in somehow. So this one goes in, so it's concave. This one that does not go in at all, call it convex. And sometimes they say non-convex, which would mean concave. Equal angular, if all the sides if all the angles are the same and are congruent, equilateral means all of its sides are congruent, and regular means all of its angles and all of its sides. In some of your homework, they might ask you to draw a quadrilateral that's regular. So it has to have four sides, right? Four sides. All the angles have to be the same, and all the side lengths have to be the same length. So I'm thinking, okay, if it's got to have all angles the same, there's four angles, it's going to have to be basically a square, right? A regular quadrilateral is going to be a square. So I'm going to label the diagram so that you can see that the angles are right angles. And I'm going to also mark the sides to show that they're all congruent. A quadrilateral that is equal angular, but not equilateral. So all the angles need to be right angles, but we don't want the sides all to be the same. So that'd be an example of a rectangle. Once again, I'm not the best drawer, so how do I make sure I communicate what I'm trying to show here? I have to mark my diagram. Okay, put right angles on there, and I'll show that this side is the same length as this side, but this side and this side are not the same. So I mark those differently. A quadrilateral that is equal lateral but not equal angular. So for this is what we actually would call a rhombus. So these angles look like they're the same, but these ones over here are different. And we can mark that all the sides are the same. So once again, my drawing is pretty terrible, but if you look at it and you look at the markings, it clearly communicates equilateral, all the sides the same, but equal angular, but not equal angular. The angles are not all the same. We can talk about diagonals, and we're going to actually use this to talk about some of the interior angles in a quadrilateral in a second. But a diagonal, a segment that joins two non-consecutive segments. So segment AF would be consecutive. They're 2 points that are consecutive. They're in a row. But if we connect A to E, they're not in a row. That makes a diagonal. So this hexagon has 3 diagonals. And we'll get more into this later, but to name this hexagon, we can just name it by each corner, each vertice. That's one name. You could also start at a different point. I could also name this B, C, D, E, F. Or you could start at A and go the other direction, A, F, E, and so on. There's a lot of different ways you can name a polygon. Okay, the first one. So using the idea of the diagonals, we drew in just one diagonal, and that split it into 2 triangles. Okay, if you look, the angle 1 plus angle 2 plus angle 3, we know all 3 of these angles add up to 180 degrees, and we know all 3 of these angles also add up to 180 degrees. So 180 degrees plus 180 degrees is a full 360 degrees. So the sum of the measures of the interior angles of a quadrilateral, it's 360 degrees. So that way we can use that to solve for x in an equation like this. I'm going to add all these together and set it equal to 360. So the sum, x plus x plus x, I have 3 x's, minus 20 and a positive 80 make a positive 60. So subtract 60 from both sides and divide by 3. X equals 100. Okay, and so this is 100, that's 80, that's 100, that's 80. There's your homework.